problem we were asked to solve is reducing the effects of greenhouse gas emissions that are produced during a food waste process. So under anaerobic conditions, greenhouse gas emissions are highly prominent. So we focus on an in-vessel unit that operates under aerobic conditions, which produces less emissions and a high-quality composting product. We wanted to focus on a economically feasible project, so we did break even at a competitive rate. To describe the process a little more, we start with an inlet tank, two of those. So there's a bulky material tank and an organic waste material tank. That goes through a screening and shredding process, which then goes to a reactor. So our reactor focuses on aerobic conditions, like I said, and the microbes decompose the organic material while also producing biogas. So the biogas is then filtered through the biogas filter. And then after the reactor is complete with its cycle, the product goes through a maturation stage, and then it goes to industrial bagging unit where it's bagged and then set for selling. So under anaerobic conditions, which are found in a landfill, air isn't allowed to get between the food waste. So there's no oxygen for the food waste to decompose. And so that produces a lot more methane gas. Under aerobic conditions, where the process is continuously churned, there is oxygen that's allowed to get into the decomposing process, and the gases are way less prominent as a product. I had a great team that I got to work with. We focus on cross-functional group work. So we found our strengths and then we delegated tasks to fit those strengths. I've had years of schooling, so this project allowed me to culminate all of that schooling into one final thing that we are really proud of as a group. And our team worked really hard together to produce this cost analysis and just overall process that is something feasible. But yeah, I just had a great time working with my friends overall too.